So the expression, which expression represents a difference of squares? So a difference of squares is a pattern. Well, let me just write it out. If I say a plus b times a minus b, it's going to equal a squared minus b squared. And that's called the difference of squares. So that's the pattern. And basically, this comes up quite a bit, actually. Where does that come from? Well, if I plug this in, and I say a plus b, my a's always look like 9s. I get a little excited on the a. Minus b, what's a times a? A squared. What's a times b? A, b, it's not c. What's a times b, or a times negative b? Negative ab. And what's b times negative b? Negative b squared. So just the nature of this thing, what happens is if I have a positive AB and a negative AB, they cancel each other out. And that's why we have this. So when we go to factor things, if I see something squared minus something else squared, then that is what we call a difference of squares. So if we look at this, I have a t squared. Is that a square? Yeah. Is 100 squared? Yeah, because 10 squared equals 100. But it doesn't have a minus sign, and this is the difference of squares. It has to have this minus sign. That one won't work. I'm going to skip down here. I have 4x squared. Is that a perfect square? Yeah, because that is like 4x squared. What about 16x? Well, the 16 is a square, but this x is not squared, so you got to cross that off the list. Same thing here. The k isn't squared. But look at this one. Is 81 a perfect square? Yeah, it's 9 squared. What about negative 49? Is 49 a perfect square? Yeah, that's 7 squared. Is y squared? Yeah, y is squared. So this is a difference of squares. That's the right answer.